Awesome. We are now recording. This is our 4th meeting of the year, I believe. Yes, awesome. This is our collaboration with the Amateur Radio / RF Club at OSU. These two lovely members, Nathan and Deep, are part of the Amateur Radio and RF Club. And today we'll be talking about software-defined radios. Exactly what that is. So this is a USB module that has a full radio inside of it. Well, full quote, because it's software-defined. The kind of program here, program radio here, that's able to control it, to get information. So we're going to be going through a kind of software to look at these very pretty kind of waterfall radio graphs. Yeah. So this is our contact info. Our president is out on studying duty. I believe he has a fairly large midterm coming up. Max is out on robotics. Chris is also out. So I'm the vice president, Connor Behite. And we have our lovely workshop coordinator, Siddharth, right here. If you're not part of our Discord server, you can go ahead and join our Discord through there. We'll have a slide later on to get you to the link if you're not already on there. We're doing office hours on the off weeks. So if you want to come in and get a lot of hands-on work with our all of our equipment and such, we actually have some of the equipment right here, function generator, power supply, et cetera, et cetera. We have a lot of stuff. If you want to work on personal projects, go ahead and work on them. So off weeks, so next Monday, as well as by appointment. So if you email us at electronicsosu@gmail.com to get a little bit of extra time in, we can definitely work something out. Yeah. So this is contact for the radio club. We have our president, Deep, right here, and the future semi-president, Nathan, will be giving some slides a little bit later on.
Yeah, we're a small club, and that's just everyone else.
You have precedence by default.
Yeah.
We're not even joking.
That is exactly how we got our positions as well. So we understand as fellow engineering clubs. If you want to follow along with the slides, you can go to electronicsclub@osu.edu, or sorry, .osu.edu. If you are actually following on a laptop, I actually do recommend pretty highly.
Yeah, we got links in there that will be very useful later on.
Yes. If you didn't get attendance earlier, here it is. Everyone got attendance? Awesome. We have some open officer positions coming out. Myself and many of the other officers are going to be leaving here soon. So we have president for training, vice president, treasurer, funding and sponsorship, and just a general officer. So as president, you oversee kind of all of the club's affairs. You send the most emails and look over the emails the most. Vice president kind of picks up the slack. Anything that needs to get done can get thrown onto by the president. Treasurer, of course, does all the finances or orders pizza. So these are looking for next semester after I and many others are gone. You can go ahead and send a message to electronics@osu.gmail.com if you're interested. It's very fun, and you get full access to the club room, so 24-hour access, which is very nice, as well as just general stuff. Edward will be staying as the president for next semester. But yeah, we're looking to fill these up coming here soon as well. So if you are a sophomore or junior and you're interested, go ahead and shoot your shot. Or freshman, because you'd be a sophomore by next year. We have an announcement from the radio.
Yeah, so if you want to get licensed, it's really easy. Even a basic level of electronic design and then maybe a few days looking at the rules. We're going to be hosting a amateur radio licensing exam for free. You just got to sign up. You can register at waltve.team. Again, it's free, doesn't cost you anything, and then that allows you to make transmissions on all the ham bands for what level. So if you wanted to say, like, I don't know, you can do all sorts of stuff. If you want to transmit, you can transmit on like radio, you can transmit on radio frequencies for two-way communication. You can set up repeater networks, stuff like that. And normally the upper bands, like if you wanted to test stuff with Arduinos and whatnot, you can have access to those bands legally. It's just really cool, and you get your own call sign. You know, it's pretty cool. I encourage you to do it. The more people that get licensed, the better. You can talk to Deep probably for more info.
Yeah. So if you didn't know, there's certain bands of the kind of RF transmission spectrum that are very, very illegal to transmit on without a permit.
Actually, most of it is illegal to transmit on without a permit.
The majority of the numbers are very illegal. So in order to be able to transmit legally and receive, or sorry, you can receive anything, but you have to have a permit to transmit.
Yeah.
You need this kind of special licensing exam. This is, again, hosted by the RF Club. And if you want more information on cool things you can do with RF, go ahead and join the RF Club, or just kind of talk to Deep or Nathan after the meeting. You want me to do these ones? Sure.
So yeah, so radio signals / frequencies. Radio waves are made up of electromagnetic waves with wavelengths between all the way down to 1 millimeter to 100 kilometers. They get very big, and we can actually receive all of those. There is two major types of analog modulation. Digital, it gets a little iffy, but amplitude modulation, basically what you're doing, you're changing the amplitude of the wave, and that allows you to do transmissions. We'll use phone as an example. So if you tune your car to like AM radio, all of those are amplitude modulation, meaning as the signal gets more powerful, the louder the signal is, and as the signal gets less powerful, the less loud the signal is. Now there's the other type, FM frequency modulation, which modulates the frequency the wave is standing on, allowing for actually more clear transmission, which is why FM in your radio, car radio, sounds a lot clearer. Now there's also CW, called continuous wave transmission, which is Morse code and pretty much every single digital transmission, which is not on here, which acts more so like a, I don't know, like a, think of it like a serial bus. So it's either there is transmission, there's no transmission. That is what CW is. Now, what is a software-defined radio? A software-defined radio, it's essentially right in the name. It's a radio that is defined by software. The radio itself is controlled via computer rather than with VFOs and other components a traditional radio might be used. Now, the cool thing with SDRs rather than traditional radios, the SDR can actually sample a large swath of bandwidth at once. So this is called a waterfall. You'll see this later in the evening. This is around, it looks like the 820 megahertz is what's selected right now. But this is a whole bunch of frequencies you can all view at once. So applications of radio frequencies, CB, citizen band radio, you probably know the bands truckers live on. Ham radio, obviously, that's what we do. Police, fire, EMS. The notable thing with that is most larger cities and government agencies have transitioned to something called a trunked radio system. which is actually not decodable by regular radios. You cannot use an analog radio to decode those transmissions. You can actually decode those transmissions with an SDR or a digital radio. Schools, bigger schools use that, I think it's called the MARC system, use that same trunk thing, trunk radio system. It's actually a government system ran by the state of Ohio. It's actually really cool. But OSU uses it, but like Campus Park actually still uses analog radio systems. Smaller schools, so like stuff downtown that CSCC uses trunk radio, but I don't believe any of the other schools down there do. You can use air traffic control. All of that is still AM band because of FAA guidelines. All of it is still AM band. You can decode all of it. Maritime, same thing. That's regulated. NOAA weather. Those weather frequencies that your emergency radio can tune to, those are all decodable. Space activity. There was a time where you could actually decode SpaceX's transmissions and you could look at their satellite photos. People got mad, so hands were decoding it and people were like, why isn't this encrypted? And so they de-encrypted it. So it was a really cool few weeks when people were getting all of these pictures from SpaceX rocket launches, but actually then the feed itself was like not even encrypted. So you could just, if you were close enough, you could hook up an SDR and look at the live feed yourself. And really any non-encrypted radio signal. So publicly, any civilian is not allowed to encrypt radio signals. You can encode it, which debatably does the same thing to an effect, but only military and government agencies are allowed to encrypt transmissions. Again, amateur satellites, NOAA satellites, those are all not encrypted. So weather satellites, you can get transmissions from them and you can see the Earth from above. So you can also use direction finding applications. So the FCC actually does this. So if there's like, say there's a pirate radio, what they'll do is they'll use SDRs, find it, and then go like triangulation style like you see in like NCIS or whatever. That's actually one of the accurate things. They can actually find that. But a more common example is finding boats and distress signals. Not as common now because most boats, large boats, are equipped with beacon transmitters that connect to GPS, but
The photo.
oh yeah.
So this was actually over last year and last summer. This was the NASA MicroGMX OSU team. So this was a drone that we actually built and is currently in the club room if you want to come check it out. It's a husk of its former self and very broken down. But I was the one who worked on, me and Deep were the ones who worked on the signal tracking device here. So it fed into something called a Kerberos SDR, which just allowed us to use multiple antennas. And we fed it into a Raspberry Pi. That Raspberry Pi then used a Python program to kind of decrypt what was going on and then show us the direction of where the signal was, which was then fed into the kind of boat controller there. Yeah. So there's the point jumping off from this is that there's a lot of really cool electronics applications that you can use for this stuff as well. So RF can lead directly to a lot of really cool applications such as this.
Yes.
Oh, yeah.
One second. I can't find the slides.
Yeah. Go to.
Something that wasn't in the slides I just thought of. These SDRs, so like these can actually be used to set up GSM networks, which are older cell network setups. So 3G reception uses SDRs, and you can actually set up your own if you get enough of them. So we could effectively, if we had enough SDRs, we could set up a entire cell network that could only interface with us. You can do that with SDRs. So the SDRs we'll be using tonight are the SDR Mini 2. They're about $25. They're based on a chip called the RTL2832U. It's a Realtek component chip, originally designed for TV tuners that people discovered could actually be tuned to pretty much the entire frequency band. But it's a really cheap chip used over in Europe for TVs. But any RTL-based SDRs are about $30. You don't need to get this one. They're all about the same. It's the same internals. The RTL SDR is the original one. There's a few different variants. There's like sensitivity to different bands. You get different antennas, but these are the ones we got. One thing to note, they're receive only. You cannot transmit with these, which is fine. But if you, oh boy. Whoops.
That's fine.
Okay. Well, if you want a transmit capable SDR, expect to pay about $300 or more. That's even with the open source applications, which kind of sucks. But if we're in the ham radio world, these would be like $2,000. So they're fairly cheap, relatively. So this is where you guys start doing stuff. Go ahead and install SDR Sharp. It is Windows only. If you have a Mac, I believe we have the solution in a second. So go online, make sure you have Microsoft.NET Framework 4.6 installed. You probably do, but in case you don't, that needs to be installed for it to work. It's a little like sketchy, but it's fine, trust me. So download the complete package from AirSpy and go ahead and install it using those instructions. I'm going to eat more pizza because I have eaten all day. I have that.
Take Connor, put the slides up so you guys can find that, which is going to help you with all the links.
You can go ahead and come up and grab your SDRs here. We have a bunch of
Laptop, you can find a buddy.
Yeah, and if we're out, like, if you can't find a buddy, I got my laptop, you can use that.
If you have installation questions, you can call it one of us.
software downloads work the first time, every time. It's so convenient.
Yes, yes.
Especially in like a large group setting.
Also, it's great that when you plug it in, Windows installs the wrong driver.
Yes.
So when you first plug it in, Windows will install the wrong driver. So you need to run .x and replace it with WinUSB. That way AirSpy can.
Oh, okay.
Yeah, I really should back do the super yeah.
Right, yeah. Yeah, like 24/7. So I can see the most things on my iPad as far as like YouTube mobile. Is that like just all the frequencies playing at once?
It looks like that's around 0. So that's just chaos.
Okay. We're listening to Don.
This
Listening to the
so you can change your never really figure out how to do that.
I can't find around it. Yeah, yeah, so this is, but how do I set it to like, 433?
Something.
Yeah. So this should be- If you don't- Oh, okay. That was better.
That was nearly seamless.
See, suppose it bring up on the side.
Die. Oh, boy. You hear like something.
The software is completely stable and there's no issues whatsoever.
Oh, yeah. SDR. It's even easier for that first time. Yeah. Hey. Frequency.
That's not how you're supposed to do it.
Did you run that software? Solution is. I didn't want to be able to leave this thing.
I can't believe it's working on the Macs first. It's working on all three last Macs. Yeah. That's the same one I downloaded.
Yep. Look at the 433 megahertz we're transmitting on that. 433.
Oh, are we?
Yes. One of the files.
You're up.
Has all this stuff installed this my PC, so I just have to check
Right.
anything.
Who's having?
What are you guys transmitting? 463? Or 33.
Or 30.
Megahertz. You said this is two of
You gotta run.
Oh, step is.
It's always the first step.
Oh.
All right, as we get that done, about half of this. All right, the first thing, listen to some music, tune to commercial FM frequencies. These do not receive commercial AM, by the way. Yeah, play around with the software, get comfortable with it. It's a little annoying. To say the least.
It sounds the best. You know, I think it's
Is your step size nice?
Either of them have a driver installed for them.
Yeah, the only one I know is.
It's too busy with actual details to care about what you do.
Like shows up that
Yes.
still
What is the?
what hardware is like on here that can't be.
Well, the specific thing that turns code or whatever into regular frequencies, that's the biggest part. A lot of it is just getting these so the sensitivity of the chip needs to be changed because chips need to design labels. That's what receive frequencies and it can also sample white spots. Also, green has your accent color.
I don't know. I'm usually
So we just need to.
Oh, now it's already-
Yeah.
You're pretty far away.
That should be better. What is it? One of 3.9.
Oh, yeah, that's one of the. Well, 433.8.
I'm not even joking.
Oh, there's nothing on that's they're like 432.5, 431.
It's still get problematic.
Yeah. Okay. We should be getting,
On 4:30.
Yeah.
so what would I have to do? Just sort of like this.
Also very stable.
Oh, is your battery started to like, my brother's keyboard is like, so it's like way how bad the battery is.
It's really bad.
Yeah.
Software or spicy software. I never tried it myself, but I'm sure it's capable, and I'm sure someone can cut this up.
Great. Oh, there it is.
Hopefully. I'm hoping so.
Yeah, so I need to see it.
Oh, cool.
How is SDR get every single signal? I'm just like, it's simple.
Well, once you get like, I don't know. I believe it's like something like 1,500 miles. Samples all the frequencies going back and forth.
If the signals are quite quiet, especially commercial FM signals, click the settings button and turn up your gain. That helps a lot. And then you'll want to adjust the offset so your waterfall isn't entirely.
What did you do before?
What?
What did you do before?
I just reinstall it.
Oh.
I ran the install command again.
No, it's doing AM. The AM's clear.
Yeah, sometimes that's.
The signal's clear on.
So if you're able, so they're kind of transferable because how FM works, it kind of goes in and out. Frequency modulation. Well, if you do that with AM samples vertically rather than horizontally.
It's like a
Does that make-
factory.
Switch that. AM samples like horizontally rather than vertically on terms of the waterfall. So as the FM signal goes in, it's viewable on AM as a decrease in noise because there's less signal there.
Oh.
Does that make sense?
I feel like I'd have to see it there.
Is that a 2-2 FM signal?
Yeah, that's.
more static.
Yeah, so. Alright, so this is an admin signal.
Still not getting our.
FMS is like wide FM. See how the bandwidth thing is. So that little selection is the sampling. Those little bars beside it are actually yeah, you can adjust it. Those little bars beside it are actually attached to it. So like I'm trying to remember how you see like this is WWCD on the on the screen. That's what that little bar is.
Oh,
It's encoded in there.
yeah, it's too like vertical. The music is like shared with the text that displays it.
Does anyone's besides Connor, does anyone's software not work? Like you are not receiving anything? I'm getting no notes. So
So I got the guide on the software into the Discord.
yeah. So if you guys want, your car keys transmit radio signals. Very small ones. That's how they unlock and lock your car. They live about 315 megahertz. So if you want to take out your car keys and try to unlock your car, you'll see that.
Oh, that's cool.
Here's something cool. It's not really useful right now. So anything that transmits a radio frequency must be registered with the SFC unless it is radio equipment. So your calls, when you get a call sign, like hand equipment, it's not registered with the FFC. It's certified, but it's not registered because your call sign, you were the one registered with the FCC, not us, not the park. But so say like your Ring doorbell, Wise cameras, all of those are registered with the FFC because they transmit radio signals. If on the little device there is an FCC ID, type that into the FRS database, and that will give you what frequency it transmits on. And that's how like pen testers do stuff. So like you can monitor those frequencies and you'll see it transmit. It's really cool. But your car keys are the same way.
Someone just took part of these, I have extra.
Same with garage door openers. There's a video, I forget who did it, but got an SDR, recorded what the garage door did, and then played it back and it opened the garage door.
Oh, so can you do that with some of the car keys?
Older card keys, yes. Newer ones use something called a rolling gate. And they don't work. I would hope not.
Yeah.
It's kind of like 2FA, but with radio.
So basically.
Yeah. Good. All the boosts.
So we're gonna work on, we're gonna send a SSTV signal with this SDR. This is a transmit capable SDR. We're gonna work on that. But if you go on the slides and the one after this, under Go Find Foreign Signals, you can download a detailed band plan, and that will tell you what the bands are reserved for via FCC. And then radioreference.com, that will let you determine, so like if you find a business signal, these will actually, radio reference will actually list what signal, what business uses, what government agency uses locally. So if they have call signs or a bandwidth frequency, so like Columbus City Schools has their bus route systems, their walkie-talkies, if they're on the business radio, that's registered with the FCC. And radio reference will actually tell you what that is. It's actually a really cool thing, especially if you have an SDR. But that band plan makes it way easier to tell what you're looking at and what's supposed to be there.
That was what it is, you have to expand it to grab all that signal. That's what it is. So we found like these little bumps.
Yeah, those are signals.
So we expanded the. That's the one you were looking for. There's this here.
Narrow FM, wide FM, and yes, the digital sideband, reverse sideband, continuously gives me non-converse. Do you want to try to do the MSTV? Something else, and I'll shut up. If you want, if you're like into like hacking and stuff, look up Tempest. It's called a Tempest attack. So non-properly shielded HDMI display port cables, put an SDR next to them, and you can actually decode the display data using a Tempest attack. So theoretically, if you walked into a secure location with an SDR up your sleeve, put your hand next to the monitor, recorded that, you can later decode and see exactly what's on their screen. Theoretically. Theoretically, yes, that would be illegal. Actually, no, it wouldn't be illegal. But depending on the remaining information you get, that would be illegal. Same with hacking. You're allowed to look, but you're not allowed to touch. It's a gray area. I wanted to do that, but like showing people how to yeah. I was like, that would have been really cool to see, but like
Yeah, it's definitely.
I probably should know.
Actively, sure.
Like going to the bank, you can see all the credit card numbers. Anything that pops up on the screen. Put it next to the teacher's computer, get a teacher login.
Yep.
Right there. Yeah, so it's night, so you don't want to travel far, but you're in 4,400. gigahertz right now, so you're gonna want to drop.
Oh, wow, it actually picked up the.
Zero.
I don't know how. it won't
Try to
change.
change that. Yeah.
It's probably the shortest thing. We're 65.
So this is definitely.
Good question. I'm not even joking. Like when I do my SDR, I throw the antenna out the window.
So why? I don't know. I messed up it. So you're trying to change a different channel, but it's just like, no matter what I change, it's just always on the station. It's like attached to the station, no matter what.
I don't know. How many times have you had to start?
Did the tutorial of that?
I think yours is just broken, but
Didn't actually look at it. I just started messing with everything.
Yep.
Yeah.
literally just.
What were you looking for? One
It's not guaranteed to be a name.
Shortwave broadcast RF. CD radio might be a little bit more active at this time of day.
I was just curious a little bit more.
Oh, Connor's laptop for some reason doesn't like SDRs.
It's not supposed to like anything.
Now we have one. Still that one. Maybe that's what, was that the station you were looking for? Maybe we found it.
During the day, and maybe not the, like, surrounded by parking garages. That would give you a lot more, because frequencies travel a little farther within the day because of certain atmospheric conditions, but do that. The BBC is actually broadcasting shortwave starting like last week due to the Ukraine invasion. They broadcast 5 to 7 every single day, so you could probably pick that up. Just make sure you're higher up. Yeah, that's frequency probably used by someone else.
They go farther away.
No.
Okay.
So AM radio, commercial AM. Yeah. So the part that this is on the lower side of the frequency spectrum. When the AM Bluetooth modulation or frequency modulation, there is no difference technically. Now the difference with that is that frequency modulation is what's might be able to receive CMH ATC transmissions.
Like, I don't-
Every time we pick up any radio station, it works. It's always that one.
OSU, airport. The local
Even said like the bottom,
You
like
might
second like the previous, it's
Yeah.
still just that one.
Yeah.
I definitely think it's just broken. This is the only radio station we're allowed to listen to.
Try turning it off and back on.
Yeah.
Oh, yeah.
You found like a bunch of other radios that are better.
Literally just download it in the file location. So. Oh, I don't know if it works with the.
Yeah.
That's for the.
Yeah, we might have to get back to you.
If you're interested in kind of maker applications, there's something called Pi SDR. There's a similar program that works on a Raspberry Pi. You could record SDR radio signals into a Python program. So say you have the car keys. You record what the car key signal looks like, and then you can set a signal for anytime you receive the car key signal, flash an LED, or do something else, or record less. Yeah.
Hold on. So if you don't want to buy an SDR, you can go to airspy.com, and I don't know why it looks like that, but you can actually listen to SDRs. I don't know why I put a space there. Web SDR is the bigger one.
Yeah. Saying goodbye. Old Yeller.
Yeah, they said, all right.
Someone got it working.
The thing we were transmitting on the 433 signal was using 433 transmitters. We also have the receiver. So if you this was last semester, right? So you can transmit and receive on 433 megahertz. I believe. So if you want your project to use some RF signals, you can use these transmitters. We have many of them as well as the receivers. Our next meeting, I'm going to borrow this.
Okay.
Okay, yeah.
Next week's meeting is on audio amplifiers after spring break. I think it's the first Monday after spring break. So remember us time comes. I believe Siddharth and Matt will be doing that. It's as boring as it sounds. It is pretty interesting. We might even get a kind of transistor radio working. So it's a radio that works exclusively with just transistors and antenna, which is really cool to see. And if you ever want to implement that, you don't really do that in a lot of institutes. They're not super great with analog circuits or teaching analog circuits. Yeah. So we can show you the way. But yeah, that was our SDR meeting. Thank you everyone for coming.
Yep. Feel free to mess with the SDRs as long as you want, but not too long. Tired.
Yeah. So it's like, it's walkable, but it's like an hour. It's like, you know where the line is? But, so it's like, yeah, yeah. Because, you know where you're at. Okay, so like you head from here towards like the tower, so. Just keep heading that direction, that's where you'll run into, clinics.
Well, got all that picture printed.
And then the train is just-
Yeah, right. Well, at least we know how to do it now.